So that was a lot of deep dive stuff on slices, and you won't need all of that all the time, but as I mentioned, you should have at least heard about it. Now, slices are not just a useful feature because you can make other people dizzy by diving into slices on slices and stuff like that, but also because with slices you can create dynamic arrays. Because let's come back to that original prices array. One downside of using that array was that we had to define ahead of time how many values we'll have in there. Now, sometimes in the applications you're going to write, you know exactly how many values you'll have in a list of values. For example, if you handle some user input in a form that has exactly 3 form fields, you might have an easy time storing those 3 values in an array because you know ahead of time that you'll get 3 values. But let's say you're loading a list of prices from a database, and the data in that database changes frequently. Then when you write your code, you don't know ahead of time whether you'll need 4 or 5 or 100 prices. So having to set the length of an array in advance in your code can be a restriction that's quite annoying. In other programming languages like JavaScript, you don't have that restriction. There you can create an array and it's automatically dynamic, so you can always add and remove elements just as you want to. For Go arrays, that's not the case. Prices is an array with 4 elements, and you can't just add a 5th element, even if you wanted to do that. Now, since we have that restriction, Go thankfully also has a solution for us, and that solution again is that slices feature. Now I'll comment out this main function because I want to keep it here for reference, but I don't want to execute it anymore. Instead, I'll write a brand new main function so that we have an empty, cleaned up main function to dive into that slices for dynamic arrays feature. Let's say we again have some prices, but this time it should be a dynamic array where we can add more values whenever we need to. You can create such a dynamic slice with a syntax that's similar to what we saw before, so square bracket float 64 curly braces, but you may now also omit the length here. If you don't specify the number of items that should be stored in this array between those square brackets, Go will actually automatically create a slice for you, and since a slice always is based on an array, it will also create an array for you behind the scenes, but it will automatically ditch that array and create a new array if your slice grows beyond the bounds of that behind the scenes stored array. But we'll see that in a second. So here we can create an empty slice like this, or maybe even populate it with some starting values. Both is possible. Now we can still work with that as before. We can build slices based on this slice. We can select individual elements. So for example here, I can print prices 1. And if we run that code, unsurprisingly, hopefully, we see 8.99. Now we can also select a slice here if we want to, like this. And if we execute that, we see 10.99. So that's still possible. That all works. Now we can, of course, also assign values like this to override the second value. But what we can't do is assign values to indexes that are not part of the slice. If we would try to do that and we then output prices thereafter, it crashes because the index is out of range. I don't get this error in the IDE, but I get it when I try to execute that code. So we still can't access indexes that don't exist. But I told you that this would be dynamic, right? But not like this. Instead, there now is a built-in function in Go, the append function, which you can execute like that, which as you see here in the tooltip, wants a slice as a first value, and then a list of elements that should be added to that slice. So here we could refer to prices, which is a slice as I mentioned. This syntax creates a slice, and Go creates the array that belongs to the slice behind the scenes. And now we can, for example, add 599. And that will now append a new item, but it will actually also return a brand new slice. So it actually does not edit the original slice, but instead what append does is it tells Go that we want to add an item to that slice, and therefore also to the underlying array. Now, of course, an array has a fixed length. So what Go will do in this case is it will create a brand new array and add that element to that brand new array, which is created such that it has the capacity for that new array. So here I got my updated prices, and I can now print my updated prices here if I want to. With that, if we now run this program, we see that we got our updated prices here, which is the original prices, slice, and therefore array, plus the 599. Now, if I would print prices here as well as updated prices, so if I print the original slice and this new slice, you see that the original slice did not change. This is still just these two values, just 9.99 instead of 8.99 because we overwrite this here. But the original slice in array was not changed by Go. If you wanted to do that, you would have to instead reassign this appended slice to the existing prices slice instead of creating a new variable. Then, of course, if you do this and you output this prices slice, then you'll see that it changed. And again, Go will manage the arrays for you behind the scenes. And if you reassign an appended slice to an existing slice, it will of course also ditch that original array, which only had 2 elements before, and use that brand new array that holds that extra 3rd element for that slice instead. So memory management is taken care of by Go here. And since we now have that extra flexibility where we can always add new elements if we need to, it's way more common to work with slices right from the start in Go than it is to use arrays. You can still use fixed length arrays if you know for sure that you will never have more than X amounts of elements in a list. But if there is at least a slight chance that you might want to add new elements as your program executes, you should definitely go for this slices approach right from the start instead. Because that allows you to add elements to slices and to let your arrays grow just as they need to. Now, in case you're wondering whether there also is a function to remove elements from a slice, since there is an append function, well, yes, kind of. We can of course just create a new slice that removes the element we want to remove. If we want to remove the first element, we simply create a new slice based on the existing slice that starts at the second element and selects everything up to the end. That gives us a brand new slice that omits that first element. So with that, we of course did remove that first element, which was 1099. So that works like this. There is no function for doing that since we already have the built-in mechanism with that feature that allows us to build slices, this slicing syntax here.